Hello students, welcome to Satya classes. Myself Raj Pandey and I am here to introduce you with measurement. Now in physics we explore very small to very large quantities. When we say very small, it means a small fraction of proton or maybe lesser than this. And when we talk about very large, it may be sun, moon, stars, or a collection of stars, or the whole universe itself. Means when we say large, it means the whole universe itself. The feel of smallness and largeness. Now, to express measurement quantitatively, we have introduced you to units. You are familiar with units. We have done units and now you are master in unit. If you watched my all the videos, I am giving the link in description and from there you can watch. So now physics is fundamentally an experimental science. So this is based on experiment. Physics is based on experiments, and measurement and their uncertainties are the heart of every experiment. Meanwhile, when we talk about experiment, there are two important things we must notice about that: the uncertainty and the result. Understanding? So what is the uncertainty and why we are talking about this? So there are so many great theories be known today was in the form of prediction. Means they predicted and then by the experiment, by the trial and error method, they corrected their theories and now we study them. So for example, again you know about this, we took universal law of gravitation to explain this. Force is equal to G m1 m2 divided by r square. Now what it mean? Here again I can see that m1 m2, the product of masses and the square of distance in between them. But my question is, how we know that the force is related as a product of masses? Means how the discoverer know this? How the Newton know this, that the force is dependent on product of masses? And the secondary thing is square of distance between them. Okay, so it was a predicted theory, and by experimenting again and again he got this result. But when any experiment is done, the uncertainty is related with that experiment, and removing the uncertainty brings us to close to the true value, means the true experiment solution. Understanding? Okay, so in measurement we will measure length. In length we will measure interstellar space, means the distance between star and star and many more distances which are very large. Then we'll measure masses and then thereafter time. Okay, so let us see how many things are required for these analysis. There are some tools that you must know when you are studying about the measurement of length. So the first one is plane angle and the second one is solid angle. Now I am introducing you with two more angles. One is plane angle and the other is solid angle. Now what is plane angle? The angle you make in your copy, like 60 degree, 25 degree, these are the angle. But when we talk about a quantity less than 1 degree, we'll go to minute. and thereafter if we talk about less than minute, it will be second. So they are related as 1 degree is equal to 60 minutes and 60 minutes equal to 3600 seconds. Understanding? Okay, let me make you more clear with this. Now suppose we have an arc whose length is ds. Now we are taking ds not to confuse you. Let me tell you, ds I took here just because ds is much smaller distance, and in physics for very much smaller distance we took the distance as ds, dx, like that. Understood? Because this is very small, so nothing to worry about. ds are just a ds are just a variable which indicate the length of this arc. And now what about d theta? D theta is also very small and it indicates the angle. What it indicate? It indicates the angle. Now the radius, the center and the radius is taken as r. Okay, so these three quantities are related as d theta is equal to ds upon r, but in radian, not in degree. The answer will be in radian, not in degree. The d theta are related as ds divided by r, means the length is being divided by another length, so there will be no unit. But to represent that this is an angle, we use radian as its unit. Make it clear, please. We will use radian as its unit. Okay, otherwise ds by r will be a simple number and we have to indicate it as angle. So for indicating it as an angle, we use radian as its unit. Understand? Okay, now what about the solid angle? The solid angle is represented by d omega, and this equals to dA upon r square, and it is represented in steradian. Again there will be no unit because area divided by r square, L square, their dimensional formula of area, and r square, again this becomes L square, so there will be no unit. And to indicate that this is a solid, we use steradian. Okay, so there are close relation, it will be in between degree and radian. So let us see how they are related. Okay, when we define radian, this means 1 radian is the measure of the central angle whose arc length is the same as radius of the circle. I mean to say that arc is a length, and radius is also length. So when we move in the circumference by the unit r length, and we define it theta is equal to r by r, so it becomes 1. Now let us see how both the angle are related, means the degree and the radian. So let us see the relation between degree and radian. For this I considered an arc just of length L and it subtends theta angle at the center. Now the radius of this arc is taken as r, so it is related as length is equal to radius multiplied with theta, but where theta is in radian. And now let us see how to convert radian into degree and vice versa, means how to convert degree into radian. Now, for finding the relation, we have considered a circle of radius r. When this r rotate 360 degree, makes a complete circle. So 360 degree is equal to c by r rad. Now the most important thing is to notice here that 360 degree, which is in degree, and c by r, which is in radius, means we are converting one system of unit to another system. So we need a conversion factor. So let us see how much the conversion factor come out. Putting the value of c, which is equal to 2 pi r, we get here 360 is equal to 2 pi rad. Now this relation is very much important, and please keep this relation in your mind. Now when you divide 360 by 2, you will have 180 degrees equal to pi rad. So from here 1 degree can be written as pi by 180 degree rad, and 1 rad is equal to 180 degree by pi. Understand? So these two relations are very much important, and please keep this relation in your mind. Now we are done with the relation of radian and degree. So there is one homework problem. This problem is from Ncert book, and you can go through it or note the problem from here and solve it in your copy and post your answer in comment section. So move to next. Measurement of big distances. So there are some instrument like meter scale, you know about it. You have meter scale, vernier caliper, screw gauge, spherometer. These things now new for you, but soon you will go to your lab, your practical lab, and you will find all these things. Okay, so these things are used to measure small distances, sometimes even much small distance. Okay, so my interest is to measure the big distance. How to measure such a big distance from Earth to star or any interstellar distance? This is the problem. So for this, a popular method is used. That method is known as parallax method. So let us discuss what is this. Okay, for this method you have to do, first of all, stretch your hand like that. You can see here, stretch your hand such that your thumb is pointing upward. Now target any picture hanging on the wall in front of you. Understanding? Now close your right eye and watch the picture through the thumb. Then again close your right eye to watch the same picture. What you will observe? You will observe that your finger jumped from left to right relative to the picture. Understanding? Pause the video and do it again until you are not getting this result. You need to do one more thing. Now bring your hand a bit closer to you. Bring your hand a bit closer to you, and keeping the hand posture same, means your thumb should be pointing upward. Now repeat the scenario again. You will feel this time that your thumb is jumping a bit more. This effect is huge, and this is parallax. Now my question is to you that why it is happening so, means why the finger is jumping on closing the left eye eyes and on closing right eye. Why it is so? So if anyone know the answer, then go to in comment section and you can comment there. Otherwise I am telling you, listen carefully. This is only because when you close your right eye, then the line of sight shifted towards left eye, and when you close your left eye, the line of sight shifted towards right eye. So the difference in line of sight give rise to this jumping of the thumb. Understand? Okay, this is only because your two eyes have a distance between in your eyes about 6.5 centimeter, and this creates the different line of sight. Now this is the basic method by which we can calculate the huge distance like earth to star. Okay, so let us understand this. So the use of this method is determine large distance. So let us see how to do it. Now, calculation of distance of nearby star. So let us consider that this is the orbital of earth, and inside the center sun is situated. Now we are observing a star from position 1, and these are the background star. Background means there are many millions of stars, so we are observing only a single star from point A. Now after 6 months, when the earth takes half revolution around the sun and it comes to position 7, either this way or this way. Understand? There will be no effect. So from position 7 we again observe this star after 6 months. Now this time the background star is A7. Okay, so the angle from the two observation I got alpha, and this alpha angle is known as parallax angle or parallactic angle. Hopefully you are understanding this. So if we measure the distance of this star from position 2 and 8, there will be no effect. From 9, 3, there will be no effect. But what about 4 and 10? In the way of 4 and 10, 4 can see the star, but 10 cannot see because sun is there. This is this measurement is hypothetical a bit, but there will be no problem in understanding it. Can you observe the star from position 10? Because in between, in the path of this star there is a sun, so you cannot see through the sun. Understand? Okay, so let us see how we'll make our calculation of this distance. So let us see it. We are observing this star from the position A, or this object from the position A, and from the position B. So suppose this is situated on the earth. Now what will happen? Earth is a bit spherical. So look here carefully. You can see point A and B have a small arc. Can you guess that? Point A and B, look at the pointer. Point A and B are making a small arc, but there is some approximation, and we are approximating that AB is a linear distance, means AB is a straight line. So length of arc AB as a straight line. From our previous learning, this triangle is much similar to the previous one, because if we measure AB as a straight line, then B can say that theta is equal to B by D. Are you clear with it? Understanding? Theta will be equal to this B. B means what? B means what? The length of arc. This is the length of arc. But now this arc I am taking as a straight line. So theta is equal to B. And what is this D? D is the distance. So the theta angle, that is known as parallax angle, this can be calculated. This angle can be calculated, and this angle we know about it because we are making this angle from measuring different position. Okay, so in every question this angle will be given to you. Sometimes if not given, then distance will be given to you, because you have 3 unknowns here. But if you have 2 known, then you can calculate 1 unknown. Understanding what I'm saying? Okay, so from here we got the formula D equal to B upon theta. Let us solve a question. The question is based on this concept. I'm reading the question and try to solve the question along with me. The moon is observed from 2 diametrically opposite point A and B on Earth. Means you are observing moon from 2 diametrically point. Okay, you are observing, suppose this is the moon S, the moon is situated at S, suppose this is the moon, and you are observing from Earth. This is position A and this is position B, from 2 positions. Now the angle theta subtended at the moon by 2 directions of observation is this is degree. Okay, this is degree. The angle is written as 1 degree and 54 minute. 1 degree and 54 minute. Look at this angle. This is very much smaller angle. Given the diameter of Earth to be about 1.276 into 10 to the power 7 into 10 to the power 7. This is the diameter. Now we have to compute the distance of the moon from the Earth. Understand the question well. Otherwise pause the video and read the question by yourself. So we have theta is equal to 1 degree 54 minute. Now let us convert this, because it is using 2 system of angle. One is degree, the second one is minute. So 60 degree, because 1 degree is equal to 60 minute, and then we can simply add 54 minute. Okay, so on adding both the quantity we get 114 minute. Now let's convert, because we have to convert theta into radian and this is in minute. So minute is not acceptable in formula. So let us convert in radian. I use following step for the converting it. Just keep your eyes here. Okay, since 114 will be multiplied by 1 minute, and we have the conversion of this 1 minute into degree. Since 1 minute is equal to 2.908 into 10 to the power minus 4 radian. Understand? These are the basic calculations, and if you say that you don't know about it, I will tell you later in some other video. Okay. Now on multiplying these quantities we get 3.32 into 10 to the power minus 2 rad. Now we have theta in radian. So can I use the formula? Yes, of course we can, because also B is given. The baseline value of baseline AB is equal to 1.276 into 10 to the power 7 into 10 to the power 7. Hold on, let me make it as a power 10 to the power 7. So we have the Earth moon distance. By using this formula you can easily calculate. You know the rules of base and exponent, so you can simply solve this and you will have the answer 3.84 into 10 to the power 8 meter. Now 3.84 into 10 meter. But you can see clearly that we calculated this distance without having any error in this. So is the answer is correct? Yes, of course, according to math this answer is correct, but physics is not completely accepting this answer because it do not have any error. And we have our supposition was we let this arc as a straight line. So will there, for the calculation purpose, for our simplicity we did so, but there is no error. So is it possible that we are approximating some value and then we are making calculation on it and we are getting, no, we are getting an exact result? This is not possible. I think now you are clear with it, understand? So there will be error, and in the next presentation we will talk about this error. Okay, so we have one more thing that we can do. Once d is measured, if you have the value of d, one can measure diameter also. Means this is another application of parallax method, and your homework problem is based on this. Okay, and this is given in your NCERT book. So open the book and solve the problem based on parallax method. So let me make you clear that we have degree, we have arc of minute, we have arc of second. So how much they are, let's have a feeling. So to have the feel of how small the parallax angle, one can assume that because there is a distance very high that are we measure that distance in parsec or astronomical unit. Okay, these are the unit of length, higher unit of length. So one can measure that. Take a coin, suppose you take a coin and move it to 2.2 mile from you. How much? 2.2, near about 3.5 kilometers. Okay, now its angular diameter, when you look the coin from 2.2 mile, then its diameter will look as an arc second. Understand? Means very small, and this diameter is known as angular diameter. Now I hope you are clear with everything, and now we shall stop here. See you in the next presentation with some examples and the error determination method.